When we began integrals, the first thing we talked about was just the area under a curve. We had our limits, and we just did the integral of the function. Then we talked about between two curves. So we need to do the integral of the top function minus the bottom function. Actually, this should be the other way around. This is g of x, this is f of x. Top function minus bottom function. Then we started doing volume, our disk method. When we rotated it, we did pi times now our function squared, like pi r squared. Well, now we can do the same thing where we have two functions. The area between the two functions, that's what's being rotated. And it kind of makes these little washer things, these disks with holes in them. And washer method is the exact same thing. We have a function up top, we have a function on the bottom. We're going to square each of them and subtract them. Still top minus bottom, but now we're squared. That's called the washer method. So here's an example of how we want to do this. What we're going to do is we're going to say, first we need to find what the intersection points are. So what we're going to do is just set the two functions that we have equal to each other. So f of x and square root of x equals x squared. How can I figure out when they're equal? Well, let's square both sides, and then let's try to solve. So I'll subtract x squared from both sides, and that means that I'm not going to have, if I factor out an x squared, be x squared minus 1. So that means I have 0 equals, it would be 0 equals, it shouldn't be x squared. When I square the square root of x, it should just be x. So I should just pull out an x, and be left with x cubed minus 0. So 0 would equal x, and 0 would equal x cubed minus 1. So that means here x would equal 1 as well. So that means when I do my volume equals pi times the integral from 0 to 1 of, now what's the big function, what's the little function? To figure that out, I need to plug in f of 0.5 and g of 0.5 to see exactly what's bigger at the beginning, the square root of x or x squared. Well, the square root of 1/2 is, the square root of 0.5 is about 0.7, and 0.5 squared is about 0.2. So that means f of x is my top function, and g of x is my bottom function. So I need to do first f of x, which is the square root of x, that's squared, and then subtract my bigger one, which is x squared, that function squared, dx. First, let's simplify it. I saw pi in front, still from 0 to 1. The square root of x, the whole thing squared, is just x, and this becomes now x to the 4th, dx. Now I can evaluate the integral, still with a pi in front. This will become 1/2 x squared. This will become 1/5 x to the 5th. And we're evaluating at 1 and 0. Well, if I plug in 1, I'm going to have 1/2 minus 1/5. If I plug in 0, I'll have 0 minus 0. That's just 0. So 1/2 minus 1/5, that's the same as saying 5/10 minus 2/10. That gives me 3/10. 3/10 minus 0 is just 3/10. So I have pi times 3/10. So that means my final answer is 3 pi over 10. And that's how we do our rotating volumes for regions between two curves. Here's one more problem. I'd say pause this video, see if you can figure it out, and we'll come back and solve it when you return. Last I even gave you a sneak peek here. I'm just going to talk through the whole thing. Top function here is x squared. Bottom function is x to the 5th. Intersection points are 0 and 1. So we're going to evaluate our integrals like we've done before, and just get your common denominator of 55 here. So 11/55 minus 5/55. So 6 pi over 55 as my answer. Now the second one down here, the only issue is it's the y-axis. So we need to change this function to make it in terms of y. So to do that, what we would need to do is to raise both sides to the 3/2 power. That way, this exponent now becomes 1, which is what we want, and y will now be to the 3/2. 3/2 squared, remember when we have something, we will multiply, so 3/2 times 2 is why we get just 3. That's 3/2 times 2. Okay, so now it's 1/4 y to the 4th. If I plug that in, when I plug in y equals 1, I just get 1. When I plug in y equals 0, I just get 0. Or it should have been 1/4 and then 0. So pi times that is why I get pi over 4 as my answer.